Hey there, Mr. Weaver here, and this is lesson 5 of our Systems of Equations unit. And in this lesson, we're going to learn to solve our systems of equations by graphing. After this lesson, you need to be able to solve a system of equations by graphing, both approximately and exactly. And you need to be able to explain why the solution corresponds to the point of intersection. After this lesson, you'll know you're successful if you can solve a system approximately, which means estimating when given a graph, and you can explain why the solution corresponds to the point of intersection. So first, when we're graphing, the solution is the point where the two lines intersect. Now, we've been using this point in Desmos to help check our answers. But in this lesson, we're going to get into why that is the solution. So when we're graphing, a solution has to work in both equations, which means it falls somewhere on the line for it to work. Well, in order for it to work in both equations, the point has to be on both lines. And the only place where it's on both lines is the point where they intersect. So the solution is the point where the two lines intersect. It's the only place where the point can work for both lines at the same time. When we're graphing, there are 3 types of situations we might come across. So the first type is one solution. And that is where they intersect. So they're going to cross at one spot. That is your solution. We can tell this before we even graph or while we're graphing. If they have different slopes, you're going to have one spot where they intersect. So in the 2 lines here, the slope of the first line is 1. The slope of the second line is 2. They are different. They're going to intersect. We'll have one solution. The second type is no solution. These are our parallel lines. So if you think back to our first lesson of this chapter, parallel lines have the same slope but different y-intercepts. There is no solution. They never intersect. We can see here, looking at our equations, they both have a slope of 2, and they're different y-intercepts, 3 and -2. The third type is infinite solutions. Now, it looks like there's only one line here, but there are 2 lines. They are just in the exact same place. They have the exact same slope. They have the exact same y-intercept. As we can see in the equation here, they both had the same slope of 2 and the same y-intercept of -2. Now, here you might say, yeah, they're the same line. Of course, they're in the same place. But if you remember back from previous lessons when we were solving with infinite solutions, it's not always completely obvious that they're the same. So it might be disguised a little bit more than this one is. But they have the same slope and the same y-intercept. If this comes up, that is called collinear. And that means they're in the same spot. They intersect everywhere. There's infinite solutions. Again, when we're looking at solutions to graphed systems, it is the point where they intersect. So if the graph is already given to you, you just have to figure out where does it intersect. So in the example on the right, it intersects at that red dot there. What coordinate is it? Well, it's -2, -2. That's all we need to do for this. Identify what coordinate do the lines intersect at. Pause the video and identify the solution to your graph. Check your answer. You should have said they intersected at 3, 4. That is your solution. If you are asked to approximate a solution, that means that you need to give it your best guess of where the solution is. This is the one downside of graphing, is if the line happens to intersect in the middle of a square, it's not completely obvious what the exact solution is, so we can just estimate. If I look in my example, the solution is somewhere in the middle of the square. So I need to estimate and give it my best guess of where that intersection is. So I see that the dot is about 2.5 spaces to the right and 6.5 spaces down. So I'm going to estimate that it's 2.5 and negative 6.5. That's my best guess. We might be able to, go a little bit closer to 0.75 or 0.25, but if you're estimating and 0.5 is the closest you can get, that's all we need. Pause the video again and approximate where the solution is for your graph. Check your answer. You should have said it was somewhere about negative 6.5 and 1.5. Again, if you did 0.75 or 0.25, that's your choice. It should be somewhere around this answer. If we need to solve by graphing, and you're not just trying to get the solution after it's already graphed, then what you need to do is graph both lines. If you can't remember how to graph both lines, go back and look at the Topic 2-3 video, Lesson 8, and review the process on how to graph these lines. So the first one, we have I equals negative 2x minus 4. I start at negative 4, go down 2 over 1 each time. My graph would look something like that. For the second one, I start at positive 6, and it's going up 1 over 2 each time. So it would look like that. Once they're graphed, my solution is that red dot where they intersected. Now I need to identify that spot, which is at negative 4, 4. Pause the video and try yours. Graph your two lines and figure out what the solution is. Check your answer. So your lines should have looked like this. Starting at minus 3 and up 4 over 1 each time, and starting at positive 9 and going down 2 over 1 each time. They intersect at 2, 5. Now, the thing about graphing, you do need to know how to do it on paper, but this is also where Desmos can come in to help. Remember, when we were checking our solutions before on Desmos, you typed your equations in and graphed them. This is why we were able to check the other things by clicking on the point where they intersect, because we were actually solving by graphing to check our work for the other two types. So if you're not confident that you graph stuff right, you can always check with Desmos to make sure that you're on the right track. In this lesson, we learned to solve by graphing, which we had kind of already done when we were checking our answers. So the solution in a graph is the point of intersection of our two lines. This is because that is the only point that is on both lines. To get this, we graph both lines on the same plane, show where they're intersected, okay, as we can see in the picture. If two lines are parallel, they will have no solution. And if the line happens to fall in the exact same location, that's called collinear, which means there are infinite solutions since they intersect everywhere. And that's really all there is to solving by graphing. We'll look more in the next lesson at how this can be used in real-world situations. So now, after this lesson, do you know how to find the solution by graphing? And do you know how to estimate your solution or approximate your solution for your system of equations from the graph? And that's the end of lesson 5 on solving by graphing.